Next, we're gonna look at scalar triple product and the parallelepiped, or the volume of the parallelepiped, which is formed by 3-point vectors. So what is a scalar triple product? So if we have 3-point vector A, B, C like this, A, B, C like this, and if the three vectors do not lie in the same plane, they then form a parallelepiped looks like this. Okay, so if we want to calculate the volume of this parallelepiped, we can use this formula, and we can also use this formula. And actually, if we form a matrix from these 3-point vectors, the volume of the parallelepiped is actually the depth or the determination of that matrix. So let's have a look in Python to see how we can implement it. So here is method 1, and we're going to look at example 57. So in this example, we are given vector A is 2, -6 and 2, vector B, which is 0, 4, -2, and vector C is 2, 2, -4. So how to determine the volume of this shape, or the parallelepiped, which is formed by from 3 vectors? So the method 1 we want to use, which is using this formula. So this formula is actually a dot product of 2 first vector, and then the cross product of 2 first vector, and then the dot product of that vector with the last vector. So let's see how it goes. We're going to say here is method 1, and we're going to say that we are given different vector looks like this. Okay, A, B, and C. Then we can calculate the dot product of A and B and plus C. So we can do numpy dot A and B, actually numpy dot cross of A and B. Then we put in outside numpy dot of C. So this means we take the cross product of A and B, then we get the dot product of the result of this and C. And let's see what we have here. So we have -16, and the result here is -16. Okay. Another way that we can calculate it, which is we take the cross product of A and B, then we take the dot product of C and A and B. So here's going to be C, and then here's A and B, and we also get -16. So that is the first method, but we can also use the second method, which is this way. So let's say here this is the second method. In this method, we're going to calculate the volume of the parallelepiped using this formula. So in order to do that, we need to determine the cross product of A and B. So that means cross products of A and B, which is this value, And then we need to determine the scalar of A and B. Okay, so this is a scalar of A and B. Okay, then we need to determine the scalar of C. So here is the scalar of C. Then we need to determine the angle between AB and C. So this is the angle between A, B and C, or this is the angle between the cross product of A and B and C. So it can be determined by this way. So firstly we need to determine the dot product between A and B, AB and C. Then we need to determine the norm of A and B. Actually we have already both. We need to determine the norm of C. Then we determine the angle between A, B and C. So we put the angle in degree. Then we get the angle at 109 degrees. Then finally we can calculate the volume of the parallelepiped, and it's the same, it's 16. Okay, that is the second method. But another method that we can use to determine the volume of this parallelepiped, which is using the determination or depth of a matrix which is formed by vector A, vector B and vector C. So let's give it a try here. So if we form a matrix from these three vectors, this looks like this. Okay, so we get vector A here, B here and C here. And then the determination or the depth of A can be determined using the model linear algebra from Numpy, and then we get it, and it is minus 16. So that does mean the volume of this parallelepiped is 16. So that's it. We can have three different ways to calculate the volume of a parallelepiped, which is formed by from three vectors.